My name's Mike Haas. I'm the manager of the Simulation Analysis and Test COE with Saratech. And today's topic is what's new with Femap, and we're at Femap 2301. So starting with what that means, kind of the naming convention that several Siemens products now uses is that the first two digits, the 23, indicates the year. The second two digits indicate the month. So Femap 2301 was released in January 2023, and you can kind of see the roadmap going forward where they will release monthly updates or functional updates here all the way out through January of 2024. So there is quite a bit of agenda here, so I do want to kind of jump into this. The first topic, which I think is probably the biggest upgrade or feature that's been added, is Teamcenter integration. So this is the first release of Femap that does include any sort of direct integration with Teamcenter. And the entire idea behind that is that the Femap files can be managed completely within the Teamcenter environment. So there is a new PDM submenu here where you could access the Teamcenter environment where you're through signing in, saving, and there's some of the functionality there. And generally, this just provides a good digital thread between design and analysis, right? And it's just good configuration control. All of the ModFim files, all of your CAD can be stored within Teamcenter, and this just allows, those two, disciplines, analysis and design, to kind of be linked to make sure we're always analyzing the latest and greatest geometry. You can review any revisions, you can review the revision history to see what has changed. So it is a really powerful tool, and it is definitely the biggest addition as far as Femap 2301 goes. And what this GUI looks like here, so you do sign in to connect the user to your Teamcenter environment. This does allow kind of what we mentioned, that check-in and check-out process, and you can see the revisions and revision history. And again, in addition to the CAD, all of your ModFim files, all of your CAE data could be stored directly in Teamcenter. So this is really beneficial when you're kind of looking for data. There's a lot of times maybe it's the data stored locally on somebody's machine, or maybe in a better case it's stored somewhere on the network in an archival system, but then it's trying to navigate that network architecture to try to find the relevant data, the relevant analysis. Is this the latest analysis that goes with this part? Has this part changed at all? But now with everything integrated in Teamcenter, or the ability to integrate everything into Teamcenter, there's more linking between kind of the part numbers and the ModFims, and just a better synergy between design and analysis there. So you would save would check in a file, and then obviously to open you would check out that file, and then you would not be able to anybody else wouldn't be able to manipulate that file until it's checked back in by the user. Okay, so the next topic is geometry, and the main enhancement here deals with the automated mid-surfacing command. And there's two new options that have been added here. The remove holes and the keep untrimmed mid-surfaces. Remove holes, just like what it sounds. Once we automatically generate that mid-surface, any internal holes in the resulting mid-surface geometry would be automatically deleted. And then for the untrimmed mid-surfaces, once that mid-surface is created, any mid-surface that is found but not trimmed properly, it's kept instead of being deleted. And I'll show a few examples of kind of what this would look like, and talk about some of the benefits there. So say we have, this is kind of a pretty flat part here. This is the original geometry. We're going to go ahead and use the automatic mesher on this. We can see there's a series of imprints and some holes there. So if we had the remove holes option turned off, this is kind of the automatic mid-surface that we would see. And then we can see that there is all of these holes that still remain in the part. Obviously, we could go back in and delete all of these, but that becomes a bit cumbersome. If you were to turn the remove holes feature on, you get more of a clean slate or a clean canvas here. to, if you want to come back and print faces on it, or new holes or slots or anything like that. Obviously, you have the ability to do that now. So, but without having to go through and delete all of the holes individually. For the untrimmed mid surfaces, so both, you can see kind of the original geometry there, and then also the mid surface that was created. They're both shown for clarity here. So the mid surface was created, but now it was not trimmed if that option is turned on. And this can be beneficial when you're attempting to connect the auto-generated mid surface, say, to like neighboring portions of the model. That can sometimes be a little tricky when you do go through some of the mid surfacing commands. So this does leave it untrimmed, kind of as shown here. Okay, quickly moving through this here, some pre-processing additions or enhancements. There's been a new simulation entity which is added for 2301 that does allow the element addition and removal. And this is specific to solution 401. This can be accessed through the model simulation entities, and then you would do element add remove, or you can access through the model tree as well. Both add element add remove entities and sets, referencing multiple entities, can be created. And this will also create your ELAR, ELAR2, or ELAR add inputs, entries for your Nastran input file. So kind of talking to this picture here, kind of walk through an example of how this would be used. Say we've got this tube with a hole through it, and you can kind of see there's a stress concentration here. Maybe we've applied some sort of moment on either end, or we're pulling down on this tube. And we would expect a stress concentration to kind of develop up here. This would be the after state, I guess. But before, you could specify a row of elements here to say, once, say for example, the mechanical strain exceeds a certain amount in these elements, I would like them to be removed. And what that would do is, as we're kind of loading up this part, that mechanical strain would build up, and then you would kind of see this unzipping effect here, and those elements would be removed, and then you would kind of see the picture that you show here once those elements are removed. So kind of what the GUI looks like for this. Everything is done through the element add remove manager, and how this works is you can either do a new add remove, you can add remove sets, you can edit individual selected entities here, you can show selected entities, you can convert them to ELAR or ELAR2 inputs for your Nastran deck, delete single entities, delete all, copy, or renumber. There are three criteria types shown here in this pull down that are available for the element add remove. The first one, time. And this is available for both element addition or removal. So if you're doing some sort of transient analysis, you would pull this down and set this to time. And the other two are inelastic strain and mechanical strain. And both of these are available for removal only. So the mechanical strain example, like we were talking about a couple slides ago. And there are two options to create the element add remove entities. The first one is the ELAR option shown here. And you would use this when all of the elements have the same value, right? Or you have an existing group that you could name here, or you could select elements using the select element button. The other option is the ELAR2, and this is when you have individual values can be specified for each element. So you can kind of see down here in this box, you can select, highlight, add, remove, or delete the elements with some of these controls. You can see the element IDs here, and where we've given it kind of unique strain values for each element. So that doesn't have to be a uniform value at that point. The element add remove set. So this does create the ELAR add input for your Nastran file. And once these are all set up, they become available inputs. And then if you do want to add them to the referenced input, you could just click add to do single entities, add all, Or if you no longer wanted them to be reference inputs for the analysis, you could remove single entities or remove them all with the remove all button. Meshing is the next topic. This one is specific to the body mesher enhancements that have been made. So mesh points or hard points that are created via the mesh point editor, they are now recognized by the body mesher. So when you're either using the mesh bodies command or when you're using the mesh geometry surface command with the mesher set to the body on mesh. So kind of talking to the picture here, we've created some hard points on this body. Say we want a node specifically at that location. We could set our hard points there, and now the mesh bodies command would recognize those hard points, and it would give us a node at that exact location. If we needed to, say, apply some boundary conditions to it, maybe some fixities, or we were going to extract bolt loads, maybe at that location, we now have the ability to do that. So on the left, we can kind of see the body that has been meshed here with the hard points, and then zooming in on this one, we can see that this mesh has been skewed a little bit, that we now have a node exactly on that hard point where we wanted it. So a neat little enhancement there as well. Sticking with mesh enhancements, the line elements. So this is a mesh on mesh enhancement. So line elements that are connected to other element types here. So we've got some plates. They can now be updated when we are using the mesh on mesh command. So picture on the right here, we kind of have I'll call it a nominally meshed plate or structure. And maybe we've got some stiffening ribs here that are overlaid on those plate elements with line elements. And now we have the ability to either say we could refine everything globally like this, and the line elements would also get refined. Maybe we didn't have a convert stress, we need a more refined mesh. We do have the ability to do that. Or on the other end, maybe we don't care about the stresses in that region and we just want to capture them for stiffness. We can coarsen the mesh as well, or unrefine it, as it states here. Performance improvements, and a lot of these kind of updates are brought to the attention through Femap development by customers, by you guys. So if you guys do have any improvements or enhancements that you would like to see, obviously relay that to Femap, and they do listen sometimes. As far as the performance goes, this one is related to graphics mainly. So currently, Femap does have two different pipelines, we'll call it, for graphics. One of them is the performance graphics option, and the other one's the original OpenGL option. So when you have best possible turned on, and that's done through the file preferences menu, everything that is currently or can be supported by the performance or the more modern OpenGL technology is plotted in that manner, and then everything that is not supported is drawn in the original OpenGL. So there's a bit of a mix match there between those two different pipelines, so that some entities would be drawn or with the performance graphics, some entities are drawn with the original OpenGL. So obviously in an ongoing effort to improve this, there is a new unified graphics architecture, so that we'll be using a single pipeline that is going to be implemented over the next few releases. And then once this is fully implemented, obviously it should have a better experience for the user as far as quality, performance, and hardware support. And then once it is fully implemented, the performance graphics and the original OpenGL pipelines would be removed. So by default, the unified graphics architecture is turned off, and currently coordinate systems, geometric entities, and also geometry-based loads and constraints are supported in the new unified graphics architecture. Analysis and solver support is our next topic. So there have been several enhancements to the monitoring and recovering of results from analyses which have been launched from within Femap. And we'll kind of walk through some of these. So improved monitoring, so analysis monitoring improvements here. I like this one. This kind of helps me for setting up, say, a series of jobs or a series of analyses where we're going to, we click analyze once, but we want to run through these 5 load sets. And without seeing where it's at, maybe with that with the monitor pane open, it's kind of hard to tell where that's at in the process. So now graphically, Femap has implemented kind of this color architecture here. So a green square shown here would indicate that we're currently analyzing this axisymmetric solution 106 job. The red square would say that this is out the axisymmetric solution 103 is in the queue. A green thumbs up would mean that this analysis completed successfully. And then obviously the one we don't want to see is the red thumbs down, meaning that that analysis did not complete successfully. So it gives you a good idea graphically where you're at kind of in that multi-step or multi-solve solution without having to dig through F06 files or anything like that. So again, it's a small improvement, but it's certainly handy, and it's nice to see it. Also on the analysis monitoring improvements, there's a context sensitive menu. This is a big one for me, I guess, that I like seeing, at least this bottom one here. But I'll walk through some of these. If you were to right click on any of these analyses here, these last 4 options are new. So the continue running analysis queue, obviously it just offers you the ability to run the next job in the analysis queue, even if the previous job had failed. You can clear your analysis queue. You can load the results from, just right click, load results. And then this big one here is at the bottom, show analysis monitor pane. So previously when you launch your Femap job, if I can go back a few slides. This monitor pane would pop up. And if you were to close that pane, it's gone. And there's really no easy way, there's no way to get that back. Now you could go to a file explorer and open up your F06 file and see things and kind of preview things that way just to check in on the job. But now you can simply right click on any of the analyses and say show analysis monitor pane if you have accidentally closed that monitor pane for some reason, and it will now reappear. So again, it's a small improvement or a small feature, but it is certainly helpful. And it's good to see that you do have that functionality in 2301. Okay, improvements for the analysis set manager. Again, this is one that's not a big improvement. There's really no functional improvement. It just makes things easier on the user. Previously, maybe you were running, a Nastran Simcenter was the program you were using, and you were doing a buckling job, and Femap numbers that as 7. But there was no real connection with, well, what's buckling 7 versus what is that in the Nastran solution numbering sequence. So now when you do pull this down to say, hey, buckling 7, it's going to show you solution 105. So again, it's a simple addition, but it's certainly handy, and it does make things a little bit easier, kind of translating the two between Femap and Nastran. So a few more examples of this, staying in the Nastran world here at the top, doing frequency or harmonic response. We can do, it populates it with a solution 108, which is the direct frequency run, or we can do it with the solution 111, the modal frequency run. If for some reason you're not using any of the Nastran solver, say you're using maybe the ANSYS program, and you're wanting to do a normal modes or a modal analysis, it also does kind of parrot back the ANSYS APDL, so the N-type comma modal. Again, translating between Femap and ANSYS there, we're doing a normal modes eigenvalue as far as Femap's concerned. Well, in the ANSYS world, it's N-type comma modal for that APDL. So it's just an easy enhancement that's been made that it certainly just kind of helps the user kind of translate between those softwares. couple, let's see, post-processing, sorry, two more categories. Post-processing, this one is dealing with computed vectors. So the functionality captures additional key results, data that may not be calculated by the solver. And you can access this through the model output computed vectors command. And then kind of talking to this top picture here, you have the ability, we're looking at, maybe this is for von Mises criteria, failure criteria, and we're looking at a factor of safety here that we've specified, whether that could be 1, 2, 3, the user can define that factor of safety, but it will graphically display factor of safety based on, whether it's your yield allowable, your ultimate allowable, whatever the nature of the job was, whether it was a limit or ultimate loading, something like that. You can kind of graphically see where your lowest margins are or where there's areas of no concern. And we'll kind of walk through some of that GUI here. So there are two options. So automatically when results are read or created, it can go through and as long as this is checked, if you're on automatic and auto run, you can check any one of these boxes. It'll automatically create this option to view these. Or if you've already had it run with the now existing output sets, and then you could just check and manually run each one of them after the model has been solved. And obviously, neither one of these create the need to rerun the analysis. So it's just using the existing F06 or the existing output and just creating the option to display things graphically here. So kind of walking through the computed vectors, there are two different types: standard, which you see here with the GUI, and then user defined, where you can, maybe you can choose from an envelope combination or use some sort of API script to define them. So both of the standard and user defined, you can save them off to a library or you can load them from a library. This is particularly nice if you have some sort of standard work or standard approach, the way that things like you would like to see post-processed within your company. You could just certainly, create that library and build that out and then load or save from that library, and everybody's, working to the same standard work. That's certainly a nice feature. So walking through some of these results, some of this menu here is the element results. We can look at the solid element, the principles, and the invariants, the plate averaged, mid, stress, or strain. And then if you want to see beams and bars, you can view the von Mises stress for those. Failure theories, right? So kind of all the big ones here, the von Mises failure criteria, if you use Tresca or the max shear stress, more Coulomb stresses, or the max normal stress can be plotted graphically here. And then you also now have the option to, if you want to see the centroidal only, or maybe the centroidal and corner stresses. And then here's where that design factor could be calculated. If it's 1, 3, or 5, or whatever the prescribed design factor there can be input by the user. If you're dealing with some composites or some laminate failure theory, Hill, Hoffman, Saiwu, and Max Strain are all available. And again, these can be accessed after you run it. You do not have to rerun the analysis to create the options for these computed vectors. The final one here is the envelope results. If you wanted to maybe take a look at all of the beams, all of the plates, all the laminate locations or all the solid elements, you kind of can group these all together and view those graphically now with the enveloped results options on the computed vectors. Last one here, I got a couple more slides and then I'll turn it back over to Nika and any kind of questions from you guys. So get those questions ready. Last one here is kind of a miscellaneous, but for someone like myself, I've had an extensive background in CAE, but maybe I'm new to Femap and maybe a couple of years in here, and I know what I want to do in the model. Like, hey, I've got coincident nodes and I am not sure how to check for that, or I'm not sure how I would merge those two nodes. So Femap 2301 finally has a command finder functionality. Other Siemens products have had this for a bit, so now Femap has followed suit with that. So if I'm trying to figure out where in this GUI I need to click to coincident nodes, say I don't know it's in the tools check menu, I can simply just type in coincident, and it gives me all of the instances where coincident would pop up. Obviously, a lot of them are in the tools check menu here, but then I could graphically pick that, and then it would execute that command. And then hopefully I would eventually learn that it is in the tools check menu. But it certainly does help you come up to speed when you're a new user, or if there's just commands that you just don't use that often and you kind of forget where they're at. So I think this is probably one of the biggest improvements, especially for new users with Femap 2301. So I know this would have helped me out tremendously in coming up to speed. So for me, I think I saved the best one for last.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.